Hi, and welcome to this video on forces and solving them, specifically with angles. Imagine you're pulling on a rope attached to a wooden box across a wooden floor. The box is fairly low to the ground, so you end up pulling on the box at a 35-degree angle upward. If the box has a mass of 120 kilograms and you pull with a force of 600 newtons, what is the acceleration experienced by the box? And though this seems a little harder than what we're doing, but it's the exact same problem, just with an extra step. Let's go ahead and take a look at it. As always, our graphic organizer is where we're going to start, and for the force problem, that is going to be a free body diagram. The box is on the planet Earth. You're pulling it across the floor, so there's going to be a gravitational force and there's going to be a floor exerting a normal force upward. You're also going to have a frictional force to the left, trying to stop it from moving, but you are pulling it across the floor. You are moving. So what type of friction is that? First question you'll have to ask yourself. You aren't pushing or pulling on the box directly. Instead, you've got a rope. And instead of pulling on the box straight this way, you're pulling at this angle here, which the problem tells me is 35 degrees. And here's where the struggle comes, because all of a sudden, we're not just dealing with X and Y, we've got this angle here, we've got this problem. We've got a force that is not acting on the axes, which means, as we often do, we need to break it up into Y and X values. This force applied is acting at an angle, but it has Y components and X components. Now, from here, we can do the rest. Our givens are up here in the problem. We have a mass of 120 kilograms. 600 newtons is the applied force, which means 600 newtons is this way. And you are pulling at 35 degrees, which we already put in our drawing. The unknown is the acceleration. What is the acceleration experienced by the box? Thankfully, our equation for this almost entire unit is sum of all forces equals ma. We do that for the x direction, and we do that for the y direction. Label them with little x's and y's. In this case, we have to talk about the forces as per components. Right now I'm just going to list my forces. So in the x direction I have this force applied in the x direction minus my force friction. But in the y direction I've got this applied y up, this normal up, and the force gravity down. And two things immediately become clear. Number one, not this full 100 and 600 newtons is going towards pulling this forward. It's going towards, some of it's going up and some of it's going down. Number two, this force applied here in the y direction is going to reduce my force normal, which will also reduce my friction. What do I mean? Well, let's keep going. I'm accelerating. The box is going to move. Now, it says it's still going across the ground. It's still going this way. So which way is my acceleration? Am I going up and down, or am I going left and right? Well, in this case, it's going across the ground this way. Well, that's how I drew it, at least. So my acceleration in the x direction, I don't know, but my y direction is still 0 times my mass, which, again, cancels out to be 0, equals my force normal plus my force applied in the y direction minus m times g. Come over here to this. I know my mass. I'll get to that in a second. But I don't know my acceleration in the x direction. I don't know my FAX yet, or force applied in the x direction. But I do know my force friction is going to be mu times force normal. Now that I've got this kind of set up, I can see it. Let's go ahead and break this up. So this is 600 newtons here. I have FAY, FAX. This is my opposite side. This is my adjacent side. So using sine and cosine, I can break this up. Let's do that. So FAX over 600 equals cosine 35. FAY over 600 equals sine 35. Or, once I solve these, FAY equals 600 times sine 35, which equals a number. I'll get that from my calculator in a second. FAX equals 600 cosine 35, which again will equal a number. Let's get that from my calculator. Now that I've got those numbers, we can start plugging things in. I'm going to solve this one entirely symbolically to show some tricks. So instead of saying 600 cosine 35, I'm going to go ahead and say MAX equals force applied times cosine 35 minus mu times Fn. If you'd rather plug in the numbers and solve it that way, it's pretty reasonable. If you're studying for the AP exam, I suggest you follow along with the symbolic. 0 equals force normal plus F applied times sine of 35, or you could say angle, minus mg. If I continue on, I'll get my normal force equals mg minus my force applied times sine 35. And you'll notice that it's not equal to mg. It only equaled mg when there were no other forces going up. Once I get this, I can plug in a number. I can plug in numbers and get it, or I can just plug this entire value in over here, wherever I see Fn. And there I go. I have an expression for A coming from combining these. Go ahead and plug those numbers in. You'll get a value. If you did everything carefully, you should get 0.76 meters per second squared. If you had trouble solving this symbolically, go ahead and try solving it by plugging in the numbers. But for the AP exam, the standard practice will be solving symbolically and then plugging in. Now let's take a look at a practice problem to make sure you understand what's going on. Here we have an example drawing. There's no story to go with it this time, just a kind of setup. In this case, you have an applied force pushing up at 30 degrees, creating an angled force. Using the values you have on the screen, find every other value missing. Find the gravitational force, the normal force, the frictional force, your acceleration, and your net force. Go ahead, give it a try. The first thing I did was plug in for force gravity. It's always m times g. Well, m is 10, g is 9.8, so you get 98 newtons. Then I wrote up my sum of all forces in the y direction. MAY equals force AY plus force N minus FG. I knew because there's a normal force that still had to be on the ground. It's not flying into the air. It's not falling to the earth. It's just staying on the ground. So my acceleration in the y direction is going to be 0. And then I had to split this force applied up. Because it's a 30 here, I did 60 times sine 30 to get my force AY, or 30 newtons. For my x, I did 60 cosine 30, which is 51.96 newtons. So in the y direction, I have AY, force applied in the y direction, force normal, and force gravity. I plugged in my values and got that the force normal is 68 newtons. That one here. Once I have that, I can find my frictional force, because friction is just mu times the normal force. Mu, it says right here, is 0.3 times the 68 gives me 20.4 newtons. With my frictional force and my force applied in the x direction, I can then go find my net force. Sum of forces in the x direction equals MAX equals force applied minus force friction. Or in other words, force applied in the x direction minus force friction is my net force of 31.56 newtons. I set that up equal to 10 times AX to give me my acceleration, or AX equals 3.156 meters per second squared. If you followed all that, if you got all that, awesome. If not, ask questions. Have a good day.